We're going to continue solving all types of equations, and with these two questions, we're going to be solving by factoring. But note, these are not just quadratic equations. We have 3x to the fourth power, which means that we're going to have more than two solutions. In this case, we'll have 4. Sometimes they may be repeating roots, but we will have 4 solutions if we have 3x to the fourth power. So, first thing we need to do is, just what we do with quadratic equations, we want to set equal to 0. We want to set equal to 0. So, keep the higher power, if it has a positive leading coefficient, keep it that way. So we're going to keep 3x to the fourth on the left, and we're going to bring 27x squared over. So 3x to the fourth minus 27x squared equals 0. And we do have a greatest common factor that we can take out. So let's do that. And x squared, x to the fourth both have at least 2 powers of x, 3 and 27. 3x squared is what we can take out. Remember, we do not want to neglect variable factors. We could divide everything by 3 and get rid of the integral factor, but we'll keep it in this situation. It's not going to be much more difficult. So when we take out 3x squared, 3 divided by 3 is 1, x to the fourth divided by x squared leaves x squared. Negative 27 divided by 3 is negative 9. X squared divided by x squared cancels. So these are my two factors, but we're not done factoring yet because we have the difference of two squares. Here we can factor again. 3x squared times x minus 3, x plus 3. So we're factored completely now. And now that we're factored completely, we're going to take each factor and set each factor equal to 0. So this first factor, 3x squared equals 0, does yield a double root of 0. So divide by 3, divide by 3, x squared equals 0. Square root, square root. So x is 0 and 0 is a double root. Next, x equals 3, and of course x equals negative 3. So 0 and then positive or negative 3. 0, 0, and then positive 3 and negative 3. 4 roots here. A double root of 0, positive 3, and negative 3. Solving by factoring. Continuing to solve by factoring, again, this is a cubic equation. The highest degree exponent is 3. So we are going to still set everything equal to 0. So these two terms on the right need to come over to the left. So x to the third plus x squared minus 4x minus 4 equals 0. 1, 2, 3, 4. 4 terms. Anytime we have 4 or more terms, we should probably try to factor by grouping. So that's what I'm going to do here. And factoring by grouping, just a quick review of that. Cover up those last 2 terms. Focus on the first 2. What's the GCF of the first 2 terms? It is x squared. And when we take x squared out of the first 2 terms, x cubed divided by x squared leaves x. X squared divided by x squared leaves a positive 1. All right, slide to the second 2 terms. Negative 4x and negative 4 both have a common factor of negative 4. What remains? Negative 4x divided by negative 4 is x. Negative 4 divided by negative 4 is a plus 1. And what we are anticipating is that we will now have a common factor within those parentheses. Bring it to the front. And what remains? X squared minus 4. And x squared minus 4 is the DOTS. It's the difference of squares. So we can factor again. X plus 1. And then factors of x minus 4 are x minus 2 and x plus 2. So 1, 2, 3 distinct factors which are going to yield 3 distinct roots. We're anticipating there being 3 answers. X equals negative 1, x equals 2, x equals negative 2. So our roots in roster notation, negative 1, negative 2, and positive 2. Solving by factoring. Solving by factoring, of course, put it in descending order, set equal to 0, factor, and solve.